Howdy everyone, Dr. Nirego here. So I prepared a simple demo of an MTI, the moving target indicator algorithm. We'll learn what it is and show how it works. So I'm talking to the AI agent. I call it Baba. I'm saying, hey Baba, I'm delivering a short tutorial on MTI. I want you to go into the demos folder and read my MTI demo Python file. Explain it to my listener. In words, using also the relevant math and intuition. Do not forget to give insights into the memory of this simple MTI filter. Start with what is MTI, single pulse counselor, and my implementation. LaTeX doesn't render, so use text best you can. Let's see what the agent Claude Code will come up with. Okay, so it's reading the folders, the MTI, inside the demo folder. It's going to take probably 10 more seconds and 15 more seconds. Now it's reading the implementation, not only the demo. That's inside the SDK, by the way, available to my Academy members, academy.drnirego.com. So, and I started actually explaining. Here's your tutorial walkthrough. What is MTI? Moving target indication, it's actually indicator, is a radar technique whose single job is suppress returns from stationary targets, clutter, and keep only returns from things that move. Walls, furniture, the floor, all these reflect the radar signal strongly and consistently, frame after frame. A person walking, a hand waving, breathing, that these changes between frames. MTI exploits that difference. So it's kind of like the background estimation in image processing. We're trying to estimate the background of the radar return and remove it. So the core idea is if something looks the same in two consecutive radar observations, i.e. it's the background, stationary, and we will subtract it out. Whatever remains must have changed, i.e. it moved. So the single pulse counselor is just frame difference. It's kind of like differentiating between difference between two consecutive frames in video, but this time in radar. It's called a single delay counselor or single pulse counselor. Basically, the output of this operation is the data at time k minus the data at time k minus 1, and usually it's the range profile that are getting subtracted. Okay, so take the current frame, subtract the previous frame. It can also work on the pulse domain, time domain. Anything that doesn't change between frame k1 and k cancels to 0. Anything that did change, survives. Okay, this is elegant but very aggressive. There's zero memory, I mean, just one frame of memory, one PRI, pulse repetition interval. It calls it frames, but it's not a frame. It's actually, it's not a camera, what we call it frames or images. This is a PRI, pulse repetition interval. Okay? And it treats the previous frame as the perfect estimate of clutter, which is not. Okay? The implementation that I chose is alpha filter, and it's going like that. The output is the data minus the history, and the history is being estimated by this filter. So we set an alpha. Alpha can be any number between 0 and 1 times the data, times k, times current data, and 1 minus alpha times the history. Okay, so it's doing subtraction here. That's the background subtraction, and line 2 is the update. Okay, so it's kind of like a common filter implementation when there is the prediction and update. That's the same type. Okay, now it references from the code. See output data minus history, and history is alpha times data plus 1 minus alpha times history. The row of alpha, when alpha is 0, there is a bypass, nothing happens, no filtering at all. When alpha is 1, that's the single pulse counselor. Okay, so history becomes exactly data at k. And if it's not 0 or 1, if it's something in between, there is a memory to this like time constant, if you will. And this tau, this time constant, is minus 1 over ln, the natural logarithm of 1 minus alpha in units of PRIs. Okay? So an alpha of 0.1 gives tau of approximately 9.5 frames. An alpha of 0.8 gives tau approximately 0.6 PRIs. Okay, frame is a PRI here in this context. And this demo actually shows that exactly. Let's uh, let's tell Baba to run the demo for us. Let me fire it up. He says you want to proceed. Have to give it the permission, right? So let's say yes, I want to proceed, and we have the demo. Now inside this demo, you can see here that it's an MPI comparator. You can choose the antenna that you wish to run this demo on. You can choose the raw, no MPI, MPI filtered, and background estimate. And you can see here that the alpha can be changed using a slider. If you take alpha to 0, nothing happens. There is no background estimation. Okay? If we take alpha, let's get it all the way. Alpha is 1. You can see here that this is a single delay counselor, single pulse counselor. That there is no memory of the filter. It's only the last frame all the time. And lastly, if you take alpha to be something like 0.84, you see that it's 0.55 PRI. If you go down with alpha, you increase the number of PRIs or the IIR filter memory. Okay? And you can see here that there is a, a stationary target at I don't know, something around zero point 0.7 meters. There is me here. There is myself here. I'm the one. The radar is pointing at me. I'm not pointing also on the walls here behind me. So at meter point something there is myself. I'm obviously moving and talking for this presentation. So I'm filtered out of the clutter, so to speak. And you can see here that the rest of the spectrum here is flat, so to speak, except for my target and some shadowing behind me that is happening. You can see it here. That's a multipath of myself. And this is the background estimate. This is very cool. If we if I go ahead and I point this radar now at a corner reflector where at a place where nothing moves, let me do that. Okay, so I pointed it at a place where nothing is moving. Let it come down. You can see here that there is a flat type of response uh, comparing to the actual targets that are 40 dBs, 40 dB of power, relative power, relative full scale is 60 dBs in the full scale. Here, at least that's the crosstalk between the antennas that we see here. We see that everything here is below 30 dBs, most of it is 20 dBs, so it's filtered out all of the stationary cloud. Now the response of this filter is about 8.5 APRIs, which is a fraction of the CPI. Okay, and you can see the CPI count here. And that's it for this demo. This is the moving target indicator. Sometimes in radar we use it before we do the range Doppler FFTs for uh, for better suppression of the clutter or the targets, the false targets near the DC, near zero frequency, zero Doppler. Zero Doppler is non-moving target, right? Stationary targets. All right, guys. Until the next lesson, read it out and see you in the program.